In this circuit, NAND logic coupled with resistor-capacitor pairs are used to produce a digital square wave at a certain frequency and duration. Components of both parts of the circuit are shown on the screen. You can pause the video if you like. The main parts of the Part A circuit is the pull-up resistor and the NAND gate. At rest, the NAND gate outputs a low from two highs and the LED flows from high to low, turning it on. When the push button is pressed, current is grounded and the input becomes two lows. This outputs a high of 9 volts, and since there is no voltage potential across the LED, it turns off. This is part B of the NAND gate oscillator. At rest, this NAND gate produces a low from two highs. In the NAND gate truth table, when one input is low, the output will always be high. So then a high is generated on this NAND gate, charging up this capacitor and the other input of the second NAND gate, as well as both of the inputs on the third NAND gate. Now current travels to ground and produces two low inputs on the last NAND gate, outputting a high of 9 volts and creating a voltage difference of 0 across the LED, turning it off. When the button is pressed and released, an output of high is created from two lows, instantly charging up this capacitor. Now the capacitor begins to drain its charge through the resistor and creates a high on this input of the NAND gate. Since there was already a high on the other input on the NAND gate, this produces a low and this capacitor begins to drain through the low of the second NAND gate. This creates a low on the third NAND gate, outputting a high and then a low for the fourth NAND gate, turning the LED on. Once the capacitor reaches a charge of 4.5 volts, current begins to switch directions, creating a low on the input which outputs a high and then a low. Now the capacitor can drain through the low of the third NAND gate and charge up the other way, providing the fourth NAND gate with two lows which outputs a high, turning the LED off. The constant back and forth in a 50% duty cycle continues until half of the charge on the first capacitor runs out, since NAND gates process 4.5 volts and below as low. All in all, this circuit is the key to achieving a true square wave by turning analog input from resistor-capacitor pairs into digital square waves through the processing of NAND gates.